looking to some of the other critical minerals, our scandium, for instance, and I'm talking in rough numbers now, you're looking at approximately 60% coming out of China, and then you have sort of 30% coming out of Russia. So that's an incredibly restricted supply chain as well. But if you look at pricing, you have extremely high prices because, again, you only need a small amount of scandium to alloy with aluminium. They can command prices of sort of 3,500 and even upwards per kilogram of scandium metal, depending on the purity, of course. And then you have dysprosium and terbium, which are your heavy rare earth elements, the most valuable critical minerals. They're sort of around that 90% as well, controlled from China. And the thing about Chinese supply is that they don't just control the in-ground resources, but they more importantly control the processing routes. Even if you had a rare earth asset elsewhere in the world, let's just say it's in the US, for instance, those projects are still having their ore shipped to China and having them processed there before having them shipped back. So they control all of the processing IP, and I see that as an incredibly valuable objective, I suppose, for the business moving forward. We'll be focusing on really trying to develop our own IP using institutions such as Lawrence Livermore National Laboratory, which is a DOE-funded institution out of the US, where we'll be working with them closely to develop novel technologies relevant to our critical minerals portfolio and trying to develop a processing route through that institution.